two different groups will look at the same rule. Often it's agencies who are grading their own rules, which presents interesting incentives questions. So you can either try to go back and redo all of that work and say we've done it using these standards, or you can try to take everything that the agencies did and add it up. But the agencies themselves only are required to do analysis for rules that are going to have an effect of over $100 million. So they leave out a lot of things that could have effects when you congregate them together. They don't necessarily do retrospective reviews to see if they were right. OMB produces basically a score that's adding all of those together, but they only look at major rules for 10 years because that's when they think the reliability window ends. And the other thing that you miss when you look at it that way is the opportunity to have interaction effects. So a single rule, when you look at it, could have a certain amount of net benefits, which is an important thing to know. That's helpful for knowing that for a single rule. But when you look at the phenomenon of regulation as a whole and the amount of complexity that adds to starting a business, running a business, that's something that you can't approach by that angle. Right. So certainly cost-benefit analysis, hugely important in the field of regulation. This is not necessarily a counter to that, but it is an addition to that so that you can look at the economy-wide effects in a broader way. No, but you are certainly right, and Patrick would be furious with me if he thought that I was saying that he invented the idea of seeing what regulations do to the economy. That is absolutely true. And so we want to look at how do we measure regulations, what industries does it apply to, and then how are different agencies acting. And so I'll walk through very quickly the major versions this has gone through. Version 1 just looked at 2- and 3-digit industries in what's called the NAICS, the North American Industry Classification System, which is a hierarchical way of categorizing all the industries in the United States. They revise it every 5 years. At the 2-digit level, it is the most broad. It's something like manufacturing, information, very, very broad categories, down to the very detailed levels, specific types of corn production at the 6-digit level.
What's a 3-digit? What's an example of a 3-digit?
Chemical manufacturing is a 3-digit. Rail transportation is another. So that's about the level of specificity. The way that they originally wanted to get at industry relevance was by generating by hand, poor guys, a list of specific search terms that were thought to be relevant to an industry by having, I think it was a set of 9 rules. So the name of the industry, the name of the people primarily engaged in the industry, things like that. And searching to see how many times those words appeared in a text, multiplying that by the number of restrictions, then you could index that. So that's something that at the time was considered to be pretty innovative. When I found out about it, I thought it seemed like an awful lot of work to go through and do that all by hand. But it was sort of an intuitive version of essentially a regression model, figuring out which terms are going to be the most important. Originally covered from 1997 to 2010 because 1997 is when the government starts making the Code of Federal Regulations available in XML. I would not wish anyone to go and try to use that data set because it's not actually XML. It's a converted file format from the internal publishing format that they use to print. So when you think of all the nice things that come with XML, unfortunately that doesn't happen with that particular data or that particular source.
PostScript of some kind, right?
It wasn't even PostScript. If they'd used literally anything else that they could have used, it would have been easier than what they used. RegData 2.0, the versioning convention essentially every time we add a new NAICS industry level, we bump the number. Went out a couple years further, added 4-digit NAICS industries, and tried to add in Google Ngrams as weights, because when you have industries with names like information, then they show up an awful lot when you do searches for them. So 2.0, they tried to weight that at least by how often those occur in natural language. 2.2 is when I show up. We were able to use OCR documents of scans to push back the data set to 1975. Stayed at the 4-digit level, but brought in for the first time a machine learning based industry classification probabilities. There was a 2.1 that was a little bit experimental. We were using support vector machines. It was okay, but you can't get good probability scores off of it without an awful lot of additional work. So the 2.2 was a logit based model. I don't like to tell the other economists that because they stop being impressed with what we do. But that's what it is at the bottom of it. And this has been kind of our workhorse for the last 2 years for use in academic research. And RegData 3.0, which is forthcoming.
Before we go to 3, just more on 2.2, Elvis.
Sure.
So it is the case that there is an active group of people in kind of big data economics who use machine learning classification, right, to basically invalidate NAICS codes, right? We say that, you know, to what extent are the NAICS codes really representative? Because in essence, those are heuristic, right?
Sure, absolutely.
So what you find then when you look at the machine learning in terms of, like, you know, look at the correlation structure of different industries, you find that you want to have a different set of classifications. So that's not what you're doing here. So
no, what we're doing here is taking the classification by the agencies and assuming that they know what they're talking about, which is always kind of a dicey assumption, but it is one we make because NAICS is what, whenever you use economic data from the government, that's what they use.
Right.
And so if we want to tie these in to do economic studies, it's kind of the only game in town.
So if they say, so if in the Federal Register there's a rule which says something like, trawlers on the West Coast hunting Dover sole can only use certain kinds of gear.
Yeah.
Okay. So you're basically using machine learning to figure out, I mean, is the goal to figure out which 4-digit code that would apply to?
So we would take the rules that are published. So usually if they say, okay, the trawlers can only use this type of code, they have to do a type of analysis. They have to publish as part of their proposed rule that this applies to NAICS industries, whatever trawling would be. It'd be in 114 somewhere. Yeah. We take those documents from the Federal Register, and that's what we use to train our algorithm. Then we cast it out across the entire Code of Federal Regulations, which is the whole stock of regulations published annually. So we are using the labeled data from the Federal Register to predict the unlabeled data in the CFR.
What just out of curiosity, what fraction of it is labeled and what fraction of it is unlabeled?
Let's see, what fraction
is this
of
like,
it?
you know, is it like only 10% of it is labeled, or is it like 1/10 of 1% is labeled?
It is closer to a tenth on that scale. It's certainly not all of them. Some agencies, especially agencies that only regulate one industry, tend not to label theirs, and so we have to kind of glue those in other ways.
Okay. And then when you go back so far, I mean, NAICS is only from the 90s, so if you go back to the 70s, you're going to have SIC codes instead of NAICS codes, right?
Right. So if you were going to be using, like, gluing the RegData results to the economic series that go out before that, either sometimes the relevant agencies that produce the economic data will have recoded it. That happens in some cases. In other cases, you have to go back and find the crosswalks and do it yourself.
So I guess that's what my question is. So imagine you have some Federal Register thing from 1979, and it does have a SIC code on it.
All right.
Would you then use the SIC code in a translation, or would you actually
all
use
of our
your
training
machine?
documents come from the NAICS era.
Oh, okay.
So to get at the point I think you're probably getting at underlying, it's probably less reliable the further we go back in time. We could theoretically now get data back as far as probably about 1950. At that point, we think it'd be really kind of an open question about whether they're talking about the same things, especially because of the changes that happened to the way regulations were written in the 70s. It's something we'll continue to look at, but it isn't something we feel like is the best use of what we're doing right now.
You'd probably crosswalk the SIC to the NAICS or vice versa, but even the structure of the industries and
That's the
Right, yeah, that
would have
becomes a
changed
question.
fundamentally in that.
I'm reminded by there's a well-known
50,
industrial organization theorist, Robert Ayers, who always says the only thing that a jet engine in 1950 has in common with a jet engine of the current era is that they have the same name.
Right.
There's not a single part in common. The fuel's all different. It's completely different.
Well, and I would throw out, in addition, they're regulated by the same entity, and probably with many of the same rules.
Maybe even the same people.
Right. So this is kind of the history of RegData, which is a data set. It's not QuantGov the idea, which I'm gonna develop from here, but just to give you an idea of what this ended up looking like. So here, for example, is our count of total regulatory restrictions across all agencies from 1970 to 2016.
It's cumulative.
Cumulative. So what we see here is that this is a number that goes up rather steadily. Something that a lot of people are deeply interested in for some reason is that it doesn't really matter which party is in power, either in control of Congress or the presidency. The slope is almost exactly the same, with two little quibbles, the early days of the Reagan administration and then actually the early days of the Clinton administration with the National Partnership for Reinventing Government, although a lot of this decline is actually OSHA taking regulations that it had printed exactly the same language for about 50 times and saying, just refer back to section 1910, whatever it happens to be. Was that did you have a question?
No.
Oh, okay.
So, this, I'm concerned about something you said earlier, which was
Okay.
The Federal Register has, when you put it in and when you take it out.
Right.
And you, I suppose when you take it out, there's not a lot of shalls, musts, prohibited, that type of thing. But if there were, those still get counted. Is no longer prohibited would still be counted.
That is true, but this is not the Federal Register.
Oh,
This is the Code of Federal Regulations.
CFR,
This is the
okay.
annual publication of all regulations that are currently enforced in the United States.
So the goes outs are part of this as well, right?
Yeah, so when something leaves, you see an actual decline.
Yeah, but the goes outs are mostly by reference to the regulation number, not to the language. To be precise, you want to say 10 CFR XYZ is hereby,
Right.
vacated, or whatever the right term is. But you wouldn't say it's no longer required, no longer mandatory or something.
Is there, I'm just curious, is there no process to, like an agency or a group of people that will automatically delete old regulations that are no longer in use?
What you're talking about is a sunset provision.
Right.
And I refer you to a wealth of excellent research on why that's a fantastic idea from a variety of researchers at the Mercatus Center and others. No, it can live forever.
But would you guys pick up ones that have sunset clause? Would that?
We would pick them up when they cease to have effect and would be removed from the CFR.
So for example, let's say that this is not one exactly, but so it's like the independent counsel, whatever law expired in '99 or something.
Yeah.
So it just does not appear then.
Right.
That's one.
So when the Interstate Commerce Commission goes away, which it did, then all of its restrictions go away as well.
Right.
And they are no longer published, they're no longer in force, and we see a drop in that section of the RegData data set. So this is kind of our top line result, some work that we've been able to do on top of this.
Quick
Go
question,
ahead. Yeah.
just on terminology. Regulatory restriction. My question is that redundant in the sense that can you have regulations that are not restrictive?
So you can have regulations, you cannot have regulations that are not restrictive, but what we're saying here is that these are specific activities within a regulation. So a regulation broadly exists as a term. We didn't want to say there were this many regulations because that will confuse people. It's like, well, did that mean they published that many rules? Regulatory restriction is just how we try to clarify that we're talking about those specific terms that we were talking about, the specific shalls, must, may not, required, be prohibited. So we're just trying to be
In the
precise
CFR.
in the Code of Federal Regulations.
Yeah, okay.
Absolutely. We've been able to tie those restrictions using the index of the CFR to individual rules. This is one of, I always say, if I get hit by a bus tomorrow, this chart is my contribution to human understanding. Because it's certainly the thing that's excited more people than anybody else. When you take, and this was true in 2014, I ran this chart just to see what it looked like now, and it happens no longer to be true, but when you in 2014 when we made this chart, Dodd-Frank by itself was associated with more new restrictions in the CFR than all the other laws from the Obama administration put together. Dodd-Frank, for those of you not familiar, was the law that the Congress passed in response to the financial crisis that they thought was going to fix all the problems with the big banks. So whether you think this is a good thing or a bad thing depends on a whole lot of other assumptions that you'd like to make. But what this absolutely shows is that Dodd-Frank is different, not just a little bit, but it's a completely different in-kind law.
Order of magnitude.
It's several orders of magnitude, and we have not really seen anything like this since the Clean Air Act of 1990 in terms of a single law being associated with more new restrictions right out of that. Like I said, that Dodd-Frank does kind of flatten out, and the others have gone past it now, so this is no longer as exciting as it was.
Just to clarify that, so basically, so it turns out the very short, the 1 minute version of it is as follows: that so a bunch of us, when the financial crisis happened, a bunch of us asked to make a new research place called a National Institute of Finance (NIF), like we have NIH,
Sure.
to provide the data which we could then use to build economic models.
Mhm.
And that was declined, and what was put in its place is something called the Office of Financial Research.
Mhm.
And the Office of Financial Research appears in the Federal Register primarily regarding data standards. Okay, so but what it says though, things like it says, for equity type this, for firm or something,
Mhm.
or for a certain kind of derivative or something, it says financial firms shall whatever report the transaction within 24 hours. So
Sure.
that's the rule now, right? Now there are at least, from my recollection of being involved with it, there are at least 10,000 different financial instruments that are
Mhm.
part of that. But it's all the same rule applied 10,000 different times to the financial instruments.
Sure.
Now is that going to be one, or is that going to be 10,000?
Depends on how they write it.
So I think it's going to say it does say. I mean, it says, like it says, for financial derivatives of this type, you shall report it this way.
Mhm.
For fuel futures contracts, you report it this way. So,
Sure.
So my guess is that's probably going to be, there's a large number of basically the same thing with just a different idea on it, different.
So a
standard.
lot of the restrictions that have come out of Dodd-Frank are either CFPB, SEC, the Board of Governors of the Federal Reserve actually for the first time emerged as a major regulatory body. I'm going from
OFR.
memory from a couple years ago. I don't remember OFR being a major contributor to this,
They were just getting
but it's
started.
possible.
And because the first thing that they published, of course, was just the data standards.
Right.
And they didn't have anything. And by the way, as a footnote, let me say, so my guy I worked with in graduate school, he's now the chief information officer at Morgan Stanley, and he said that the amazing thing about the OFR data standards was the head of Morgan Stanley could never actually get, the CEO of Morgan Stanley could never get on his main dashboard what the status of his main 7 divisions were, because he had 7 divisions with different data standards. And it was precisely because the OFR proposed common data standards that he can now get on his board. How is his mortgage division doing versus his bond division versus et cetera, et cetera, et cetera. Right?
Sure.
And so that was an area where, like, the fact that he published the standards, even though there were a large number of standards, actually makes the claim is it makes public industry more efficient.
Sure.
Right?
Sure, and I mean that is an arguable point about every restriction.
Uh-huh.
I would hope somebody usually thinks it's a good idea.
Uh-huh.
And we don't certainly pretend to be able to tell the good ones from the bad ones. That's certainly what everyone would like us to do. Say, okay, which of these are the good ones and which of them are the bad ones? We don't know. We can just tell you how many there are.
Well, that begs another question, which is
Mhm.
National Institute of Standards issues standards, and there will be new standards come out. And there are accounting standards.
Mhm.
Are those counted as regulations?
It depends on if they're written into the CFR with regulatory restriction words.
Normally they're not.
They're not.
right?
Then they would not show up.
Yeah.
And yeah, this does not count things like guidance documents.
Right.
It does not count speeches where heavy suggestions are given. It is not a complete accounting of the administrative state. We're working on it. But this series, which was the impetus for everything
Right.
that's come
This
after,
is
is
set
only
up.
the CFR. It is theoretically only those things that have the force of law, even if other things tend to actually have that effect.
But even even CFR doesn't necessarily have the force of law.
Regulation publishing
Somebody
generally do.
somebody has to have, there has to be a penalty associated with it.
Sure.
Because the Nuclear Regulatory Commission had a lot of regulations
Yeah.
that had no penalty associated with them.
Mhm. No, and that does raise another point. Regulatory restrictions, we don't pretend that is a perfect mapping to how, like, one shall could
Behavior.
theoretically be a lot more impactful than another shall.
Yeah.
Our kind of going theory is that 1,000 shalls is mostly like another 1,000 shalls. But it becomes more convincing. This is why I tend to say at the high level.
Yes.
It's a more convincing series the less into the part level, the low level data you get, at which point probably you've got some folks who actually have directly applicable knowledge, and this isn't the best way to get at it anyway.
Yeah.
Another, just kind of to show off things we've done, the phrase index was another data set we built on top of it, on top of the RegData data set, just looking at which industries were most prevalent in which states, and therefore which were most impacted by federal regulation as a whole. So you see, not surprising, the energy states have a higher impact. States that are more technology focused, things like that, have a lower impact, is sort of a broader trend. And then getting back to this question, they did eventually
The red states and the
find
blue
out,
states.
create a model of the cumulative cost of regulations, economic costs. So this is net growth versus a counterfactual if you had held regulatory restrictions across the economy in 1980. This is where it'd be great if Patrick was here, because I was not a co-author on this paper and I can't explain the model in detail. But this was the goal that we were going for, is to try and be able to answer this question: how much does it affect the economy? And they were able to come up with an estimate that is currently pre-publication with, I believe, the Journal of Economic Growth.
So, but so here, but you just give a sense of the number. So, is that going to be annual then, Oliver, or is it cumulative?
It is cumulative. So the idea is, oh, I should know this number off the top of my head. I forget exactly what the growth number is. I think it was a growth drag of about 0.8%, but the idea would be that if restrictions had been held flat at 1980 levels, the economy today would be expected to be about 25% larger than it
But
is.
so here's why I immediately mentioned the thing is that it doesn't pass the sniff test, is because you may know that the Dallas Fed estimated that the cost of the financial crisis to households was between $10 and $12 trillion.
Sure.
So the question is, if you guys are not, if you're not using that number, the real number should be something like 18, or if in fact you say that CFPB would have attenuated the crisis, then you would have a net benefit of $6 trillion, right?
Sure. If your counterfactual is that other regulations had been put in place earlier, then you would get a different number. This is measuring against the counterfactual of no additional regulatory restrictions, based on a structural model developed by Pedro Pietro at Duke. And this is the result that comes out.
So then I'm just trying to figure out whether it, so how's it dealing with housing bubble losses?
They still show up. In the counterfactual, you still see a financial crisis happening.
That dip is nowhere near $12 trillion. So
it's about the same size as the.
it's about
So here's the actual, and here's the.
But it's
counterfactual.
cumulative. But am I reading it right? That's 4 trillion, 6 trillion, right?
Yeah.
No, this is the GDP across the industries that are included in this particular study.
Right.
Growth since 1980.
Was the
So-
financial industry included?
Yes.
So in a $30 trillion, it's not, once again, it doesn't pass the sniff test. You tell me in a $30 trillion economy, the cumulative effect. Am I reading it right? The cumulative effect of 30 years of regulations is $6 trillion. So that'd be only $600 billion a year, but the economy is $30 trillion.
I think that's
Total output of all firms is $30 trillion. The economy itself is.
GDP as it's measured is about 17 or 18, might be up to 18 now, but
Yeah.
Is on that order, and that was the output variable of interest for here.
But you have it across industries. But you sum it up across industries, all industries. See, you're not using a value-added measure. But see, if you sum up across all industries, where there's double counting, it's 30 trillion.
No,
Anyway,
it is a value-added model.
Okay.
But I can certainly send you the citation so that the folks who worked
Maybe
on
you-
this structural model can explain it better than I can.
Okay.
Um,
Fair enough.
so. Was there
When
another
you say
question
it's
over here?
only those industries, about what percent of GDP is represented here?
So those are, by the way, that's 22. It's 22 two-digit industries, I'm sure. And there are 30.
22 industries as classified by BEA, which is not exactly the same thing as it's a mix of 2 and 3.
Mix of 2 and
And
3.
I think there's one section where it goes into the 4 digits,
Okay.
but it's different from anything anyone else uses.
Okay.
But again, what percent of the economy do those 22 represent?
I want to say it's about 2/3.
So it'd be close to that. NICS NAICS 2-digit has about 32 industries in it. So this is 22 out of 32, something like that.
So now I want to move on to what prompted us to get into QuantGov. And this is something that we've already started talking about. We can look at regulatory restrictions for the United States. The second that we said we could do that at Mercatus, the question was, well, what about if we did other countries? Can you do the states? Can you do something besides regulations? Can you do other classification questions besides industries? Can we solve regression problems? Can we do things like topic modeling? These weren't always the questions people knew they were asking, but it was the underlying questions that got to their point. And so what we decided to do was to take the lessons that we have learned trying to introduce machine learning into this particular question and generalize it in a way that would be useful for people who are doing research like us, who are not necessarily folks who are computational experts, folks who are maybe never going to learn how Apache Spark works, but at the same time might have something useful to add, but their data is locked into text.
So one question on terminology, Oliver?
Yeah,
So
absolutely.
You used the word machine learning several times. Now, we're used to that in the computer science sense.
Mhm.
It seems like much of what you're doing here is you're doing natural language processing, plus then trying the attribution of the meaning to it. But because you're using the meaning only through the 6 dictionary words, whatever it is, right?
Mhm.
Is it do you always use the terminology machine learning for the whole for what you do? Because it's
No,
it's
I tend to use natural language processing to talk about what happens within a corpus
Yeah.
in our architecture, and then machine learning is when we apply estimators to it.
Okay, but are you using the whole apparatus of this random forest and all that kind of stuff? You're not really doing that though, right?
Yeah, absolutely.
Oh, yeah, you are. Okay.
Mhm.
So you gonna show us any of the guts of that or not?
I can.
Okay,
I don't have slides, but I can. Except I can't hook up my computer, but
Yeah.
I can hold it up
Okay, fair
and show
enough.
you random forest.
Okay.
And I'll talk through. What I'll do is I'll talk through in detail when we get to the different parts
Okay.
how we've done that.
Okay.
So actually, I should say Logit is what I told you was at the bottom of RegData, but we also we compared it to a random forest model, just to make sure that using a parametric model was the most effective way to be doing it. No worries. All right, so let's talk about QuantGov, the framework that we have built based on the lessons that we've learned from the RegData experience. So when we started this, here's kind of how we saw the lay of the land. So there's lots of great resources out there for implementing machine learning. Nobody needs to reinvent scikit-learn. It's already there. And for the most part, if you find out about a new algorithm, generally the person will have produced some code for it, and that's great. That's a fantastic part of the field that we get to work in. There are generally fairly high barriers to entry for folks who don't have a strong computational background. If you tell an economist about LDA, they're not going to get it. And there's not a ton of standardization as to formats. So, for example, when we were looking early on at doing some topic modeling, the first thing you find out is that each time you want to use a slightly different version of the algorithm, you have to take your text and pre-sort it into a completely different format, not because one of them is necessarily better than the others, but because that's just what the guy who wrote the code happened to do his in, and so it's an extra step.
What do you say about the critique of the deep learning guys of your first statement is that they say almost all machine learning algorithms are unsatisfactory.
Sure.
Right? And so that's why you have deep learning coming in and replacing much of the conventional support vector machine algorithms.
Yeah, no, and to the extent that there's continues to be stuff developed, I think that's great. This is not an argument that we have solved all the problems that we need to, although we have certainly solved them to the point where we can start producing more data than we have from text that's out there in ways that would be interesting.
Do you guys ever go back and hand check, or for example, you evaluate some text with your algorithm, then go back and see how good it is?
Oh, always.
Oh, okay.
Yeah, absolutely. Certainly, and that's both a feature of being cross-field, and we've talked about some of the inherent difficulties of using our particular questions that we've looked at. it's always necessary to make sure that it passes, like you say, the smell test.
Yeah.
You don't just take whatever comes out of the machine, and that's hopefully not what people will use QuantGov to do. A lot of folks have talked to me about how it's difficult to move on past tutorials. I can do 20 news groups, but if I want to build something from scratch, I don't know how to get started. Really building an entire analysis from scratch is mine. Huge emphasis on big data and business environments. Well, those are the people who are inventing things. It makes perfect sense. But there's not much if you're a researcher at Troy State University or somewhere who is kind of isolated and wants to get into this. There's not much focus on what can I run on my own laptop. And a lot of tools expect you to know what you're doing, which is, again, this is all the way it is for a reason. But if you want to help people get into it, it's nice to have best practices kind of built in by default.
Have you guys encountered the critique that, because you're only dealing with the Federal Register, it's not really big data?
Oh, yeah, no, that's a question we get all the time. People ask me, are you doing big data? It's like, well, if I'm talking to big data people, no. If I'm talking to economists, sure. You know, big compared to who?
But you can say you're working with the data universe. Right? That's
Sure,
the universe of all.
sure. Our focus is not saying that we work with, I mean, and big data to a certain extent is, I forget where I saw this. Some people say that big data is nothing but another word for not enough RAM, which is, I think, a little bit slick, but there is a buzzwordy aspect to it. Everyone would love to say, oh, we're working on big data. I tend not to focus on it just because I'm not big into buzzwords, so I try to avoid that. But our focus is to say, like, even if you're not doing, you know, huge data from the Census Bureau or something like that, some of these algorithms are still useful to you. You can still find useful contributions to human knowledge and to research using these tools, and that's really what we want to unlock, because the people who can do big data stuff are doing it without our help. They don't need us. The people we want to help is the folks who can get into it, might be able to find some useful things, but the barrier to getting there is just too high. So with that, here's the vision for the framework we put together. This is not set in stone. I wrote this today, so don't take it as gospel. But an open source modular framework for using natural language processing and machine learning to create reproducible and extensible data sets from text that is accessible to reasonably motivated researchers. So there's a lot of clauses in there, and we'll dig into them a little bit more.
You haven't narrowed it to anything government related?
No, we haven't. And usually when we talk about this in terms of economics, we call this for policy analytics.
Okay.
And the reason we do that is because if you tell people you can do anything with anything, their eyes kind of glaze over. So our work, because we are a academic research center focused on public policy questions, is always going to be primarily policy focused. That's what's going to be coming from our team. But for someone who wants to go out and analyze, you know, text in a history department, this works for them too, because in an underlying sense, the math is the same, and it doesn't do any good for us to bake government assumptions into it.
I'm just keying
Yeah.
off your name for it, though.
Yeah.
If it's QuantGov, it sounds like it's going to be about Gov.
Well, it is when we do it.
But if it's QuantText, that would be a much more general term.
Yeah, but
Sure.
you have an underlying paradigm of addressing policy
Policy.
questions.
Right.
So,
At the governmental level, not the business level.
correct.
Maybe you should say, when you say from text, I mean, you know, kind of from government text, from government generated
Yeah.
text. Maybe that's
Yeah.
kind of good dealing with it.
Right.
Yeah.
So our goal is to do something that is
Okay.
primarily, for our purposes, useful in producing interesting policy research, but can be used for other things. Do you have a
Yeah.
question?
No, I was gonna say, I'll wait until you go through it.
Oh, okay, great. So here's a general architecture. Shouldn't be a lot of surprises in here. We have a concept of a corpus, which is a self-contained representation of documents. An estimator, which is a single algorithm which is trained if necessary on a trainer corpus or from other sources. And then a project, which is a central driver that glues things together. So this is sort of the most basic structure of how QuantGov project to produce a data set will work. So when I do workshops on this, what we might do is take the 20 news groups corpus, and we build that into corpus. And I'll talk more about what we call a corpus, because obviously there's the big idea of what we mean something specific by it. And we train usually a random forest estimator, and I'll run through doing it as a binary classification problem, and then a multi-class problem, and then a multi-label problem, because all those can be handled kind of by our framework. And then we run the Reuters corpus through it. So again, nothing that's necessarily tied to government, just
Right.
easily accessible things that people are familiar with. The estimator knows about the corpus, but none of these pieces have to know about each other. And I'll get into what a more complicated version of this looks like. And so the project can be used to glue any of these that have been created together so that you can build on other people's work. And that's the key here, is that anyone should be able to theoretically take the work you've done, glue it in, change one line in the make file, and then make it all work and build something else new off of it.
Is there any necessity of having a single estimator? How about if we had multiple estimators?
Absolutely. RegData has 5. And I'll get to how that one is kind of glued together in a little bit. So technical design. We tend to use, and this is all by default. Obviously, with anything technical, you can rip it apart and throw in your own choices as much as you like. But we focus on Unix philosophy, so using small scripts to do very specific topics that are as ignorant as possible about the content of what they're doing and are focused on carrying out a specific task. Saving intermediate steps, that's something that we find very important for doing academic research. You know, people want to see what's going on in between, and so that's something that we tend to focus on.
So what does that mean? Save intermediate steps, does that mean I can, it's the equivalent of a control Z, I can go back in history for my actions, or are you saving intermediate steps of data?
Saving intermediate steps of data. I wish we could control Z through everything. That would save me a little bit of time. But kind of getting at that point, we use make. Are people familiar with the make utility? Make was something that was developed, let's see, in 1970-something to help compile complicated programs that had a lot of different source files. The nice thing about make is that it has built-in dependency tracking. So you can specify recipes for each of your intermediate output and then say, all right, I've done some work, now I need to go back and change something further up the line. I don't have to run my entire analysis again necessarily. And if I've written my make file well and we hope that we have good defaults in there, it will automatically know which parts need to be rerun and then pick up your analysis just from there. So it's actually getting a little bit at the, can you just control Z? Well, not exactly. You're still editing the scripts and then running, but you're running it in a framework that keeps control of what you've done and what you've changed.
But I have to specify where the intermediate steps are.
You do have to tell it what you're making. Yeah, absolutely.
So if I'm doing a big data, I'm doing a data project,
Sure.
Say in Python, the way that I would do that is I would constantly save my new variables into variables with new names. And that way I don't lose, just in case I want to go back. So if I'm going to delete a column of a binary data column because I don't need it for some classification problem that I'm doing, I will save the variable, you know, Joe's data in Joe's data 1 with the deleted column, and that way I have Joe's data. So it takes a lot more memory. So I'm doubling, sometimes doubling the size of
Right.
of my memory usage. How would the intermediate steps process handle extremely large amounts of data in terms of memory?
So
Is
actually,
it saving copies, clones of my data every time I save an intermediate step?
it depends on how you write your script. Usually by default, it will overwrite the last thing that you did, depending on how you write it. This is something that obviously you have control of, but if you decide that the way that you did it before didn't work, and you want to change it to do something else, that makes it, by default, the way that it works is that it will overwrite those older files,
Okay.
but you'll save the files from every step in your analysis.
Oh, okay. It's like a versioning thing.
Yeah,
Okay, all right.
there you go. And we use Python by default. But part of the reason that we have a very split up modular within each type of component system is so that if you want to do all of your prep work in Python and then run it through an R algorithm, we've had running in this framework R Scala, Java, even Stata in batch mode, which I don't recommend, but it can be done. You can glue together whatever tools you need to make it actually work properly.
Well, hang on there, because
Yeah, go ahead.
our critique of that would just be that the trouble with Python is you have the global interpreter lock, so you can't do really parallel things. That's the limitation.
Sure, that is a limitation. You can run it using PyPy if you want, which sort of gets around that. That runs its own questions. If you want to run your analysis in something that can use it, that's something that you can still do if you need that kind of parallelism. You can do parallelism in some circumstances. You just have to be careful about it in Python. I agree it's not the easiest thing in the world always, but it can be done. We do most of our own analysis in Python, but if you find it's not suitable, that's why we have it modular, so that you can rip Python out for the parts where you don't find it to be suitable. So the idea here is that it makes things simple to get started the less you know what's going on, and then as you become more opinionated, it doesn't constrain you. That's kind of what the design we're going for is. In a lot of ways, I don't know if there's any web development guys here, we think of this as similar to the Django framework, and if this is a useless analogy, I'll just abandon it, but the idea is you can get your website up and running using it pretty easily, and then the more you know about how you want your website to run, you'll find yourself maybe replacing more and more parts of it because you know more. But where you don't know more, it's excellent at getting you to at least a good set of defaults for what you're doing. That's our overall kind of design philosophy. To that end, we do have a library. It's got a command line interface to create the boilerplate components. This gets us over the how do I get started? Well, it'll fill out almost everything you need to get started, and I'll talk through exactly how easy that can be. And it provides common data structures and frequently needed utilities. Again, if you need them, if you like our implementations, if not, nothing requires you to use them. So a little bit more detail. What we're talking about with the QuantGov Corpus, Corpus provides the text and optionally metadata for a set of documents that you align with a index that can have as many dimensions as you like. So to put some meat on those bones, at the when we analyze the CFR corpus is indexed using the year, the title, and the part. That gives us our kind of natural unit of analysis. And then we create a metadata document that has all the natural language processing just of the document by itself. So that's where we count our shall, must, may not required. It's where we identify what agencies wrote the different parts. Things that are kind of discernible directly from the text with no additional, no outside information needed. The corpus implements a driver, which is a Python object. Quite simple. All it has to do is say, here are the labels to my index. So in the case of the CFR, year, title, and part, and then provides a stream function that will iterate over the index and the text for each document. The point of having a simple corpus interface is so that we can write scripts that know about the corpus. They know how to expect that, and therefore don't have to know how you're storing your files, whether they're being generated on the fly, whether they're being downloaded from somewhere. It doesn't have to know. All it knows is that when it calls next on that stream iterator, it's going to get the next document. And so you can write additional scripts. So for example, by default, we add a word count and a restriction count, because most of the things we do want a restriction count that understands the driver, so that we can run that through any text that we want to get. So we have some built-in
So you,
corpus.
for example, could tell it beforehand not to count big documents,
Yeah, absolutely.
not to work on big documents.
Absolutely. So these are kind of the structures that we use most often, that we've got built-in drivers for, where essentially you just have to tell it what encoding your files are saved in and where they're saved. The recursive directory corpus driver, this is how the CFR works. We've got a folder for every year and a folder for every title, and then each part is in a file underneath that. It takes the names of the files in the folders, serves those up, and there's your index. That's about one line's worth of coding to put in. Name pattern driver. If you like regular expressions, you can just dump everything into a giant folder, use named pattern groups, and that will automatically identify the names of your index label and extract them from the file names for you. Index driver. I lied. This is actually how CFR works because we have to correct some years that aren't there. This is where you can just give it a CSV and say, all right, for these index values, serve up this file. These cover basically everything we've ever run up against in our very narrowly restricted domain. As we find people needing more, we'll probably implement more of them. But the idea is that when you write that driver file, or when you go in and modify the default driver file, usually there should be something there that can take care of your use case with minimal work. So if I were to show you the driver file for the 20 news groups corpus, I think it's 3 lines. Because all you have to do is point at the folder where you've extracted the files, and it's done. And then that can work with anything else in the QuantGov ecosystem.
So because this is, I don't know what the right word is, because it's object-based, so we're looking at the text as an object. But we'll say what I wanted to do with the standard federal text. I want to build up the network of what regulation depends on what other one. So that's what I want to do with machine learning. But it seems like it'd be hard to do that if I only have, if I'm only with this overall structure. Like I said, it seems like it's going to be tricky to. It's going to be easy to build counts and to do and get statistics coming out of this, but it's going to be hard to figure out. I don't see how I'm going to be. It's going to be hard to build a network structure.
Sure.
As the output.
In terms of building a network, and that is actually something that we're interested in doing, but I have not done much hard thinking about how we would do that. For many of these drivers, everything I think, no, including the recursive directory, yeah, anything that is a file-based driver, you can also access the driver as a dictionary, or as a hash map.
It's good hash tables.
Yeah, as a hash table, so that you can arbitrarily, if it is possible for your driver to arbitrarily access a specific document, that should be available to you.
Do I have to write all my own hashing functions, or are there things built in for that already?
It's built in for that. So that's all using the Python standard set of tools.
And what if I want to keep, in order to do some of these more intensive things, if I want to keep everything in RAM, and it says it's file based, I just have to get fancy with some kind of RAM drive or something. But there's no. I don't.
It depends on what you mean by everything.
So I want to probably put the whole corpus in RAM, and I'll put all the, and I have all the file storage go to RAM too. So I don't have to say in order to make it fast. Is it? The default obviously going to be to do it to disk.
So that's not a use case that we've run into.
Okay.
It's something that I have an inkling of how I would solve it. But if that's something that would be particularly useful, we'll figure out how to do it and we'll stick it in the library.
Okay.
Like I say, most of what we've done has been to disk. You're absolutely right. Nothing keeps you from reading the entire corpus in. Nothing at all. So
because the entire corpus is not that big, right? It's a few gigabytes or something, right? Probably.
Right. Yeah. So that's something that you can do just that way. But in terms of having something that is purely stored in RAM and is never touched to disk or is completely preloaded, it's not something we've run into. But I now thinking about it for an extra 2 minutes, I think I know exactly how I would implement it, and if people want it, that can go.
We have an exotic machine over here with 512 gig of RAM, and so I wouldn't even want to. I mean, if I had the chance to not even use a disk, it'll be 100 times faster.
Yeah, no, absolutely. I am. I wish I had your hardware.
You use it if you want.
All right. Any other questions on the built-in corpus?
If you're George Mason, you
Hmm?
You can log into it. We'll give you a
All right.
VPN.
Wonderful. So the Estimator. Again, a make-driven set of scripts. That implements a single supervised or unsupervised algorithm. By default, again, this is just your standard set of choices for somebody who wants to get started on a basic analysis. So word count vectorizer, runs it through a TF-IDF and into a random forest classifier. There's a get labels script in there that generates labels from your corpus. Obviously, if you don't tell it what good labels are, By default, it just spits out randomly. No, I think it defaults everything to true, so that's not too great. But you can't have a generic, this is what your answer should be script, but there's at least the framework there to write your label script. Optionally, if it is a supervised algorithm, you can connect it to a trainer corpus. We haven't released them yet, but we do have some GenSim-driven topic modeling estimators that don't require a training corpus. And the trainers don't absolutely have to be from a corpus if you don't want them to be, although that tends to be the easiest way. By default, we use scikit learns functionality to cross-validate. So essentially there's a models.py where you go and you say, all right, I want to try these different models using a fairly simple specification, and you can say, I want to try this set of parameters for each different model. So when you run the special command make evaluate, it will go through, cross-validate. By default, it's 5-fold, but that's settable. Cross-validate across each of your different model types, does a grid search. So if you don't know what you're doing, it's quite slow, but will at least give people something to point to, and it will suggest a model based on what was the highest performing. It does not, by default, do one standard deviation below best performance or anything like that. It just takes the highest performing estimator out of the box. And that spits it out into a little configuration file that's easy to read text. You just double-click on it, decide if you agree with the choices based on what spits out of the model evaluation, change that, and then when it goes to estimate and train, it'll just train the model that you picked. So out of the box, it's something that is fairly simple for most people to get started. How are we doing on time, by the way?
We're good. We're fine.
Okay. And then the project is a very simple file usually that just says, okay, let's take all of the corpuses that we're interested in, let's take all of the estimators that we're interested in, make sure that the ones know about the other. The project is essentially the only file that has to know about all of the others. And then if you have any finishing details, you can put that in there. By default, it'll create a frozen file that's time-stamped. Say, all right, these were the results you got on this day. And that's what you can email to your collaborators. So as a working example, here's how RegData 3 works. We have two corpora. One is the Federal Register using the XML representations back to 2000, indexed by the document number that is provided by the Federal Register. The other is the CFR, which is compiled from both scans and the downloaded HTML files, indexed by year, title, and part. We have 5 different estimators training against the Federal Register corpus, so it makes at 2, 3, 4, 5, and 6 digit levels. Again, using a count vectorizer, 1 to 2 grams, some basic document frequency filtering. We tried 2 different multi-labels. We think of it as a multi-label problem because the restriction can apply to more than one industry at the same time. So we tried 2 different models, a random forest model and a logit that we evaluate using stochastic gradient descent. We generate per label metrics because, of course, that's interesting. And we needed to filter our results later. We have 1 project file which runs the CFR corpus through each of those estimators after they've been trained, and then filters to high-performing classifiers using those per label metrics. And then we create summary extract files. So people are really interested in, what is the summary of restrictions for 3-digit NAICS? What's the top 10 at each level? Those are the things that we can send to our outreach team and to our media team because they're the most interested in those. And so we generate those automatically. So this is what this looks like in practice for a non-trivial project. But again, the point here is that, this one took a fair amount of coding just because we're gluing together different sources and we have to parse out OCR'd text. This guy's almost trivially simple. Download the XML, extract it. Here, the code is the same for each of these except for 1 variable, which is the level. Running through all of them takes a pretty reasonable amount of time. It all runs on that laptop. And then the project is more complicated than the default, but it's still less than 100 lines. Or in fact, no, the project is probably less than 50 lines. Describe everything that goes on. So here we have, with a minimum amount of additional coding, the next version of RegData. And this is how we can see the parts fitting together. Now, what we've been able to do with this framework, and we started doing this at the state level, for example, is obtain the state administrative codes, run them through these exact same estimators, because the estimators don't know that they're doing anything with the CFR. So we've been able to produce, I think, 5 states now, where we've been able to have a industry-specific restriction count. And that's something that has never been available at the state level before, because states in many cases don't know even how to get to their own administrative codes, let alone what's in them. That's something that we've been able to help unlock. We've been able to generalize away from regulatory text to look at things like trade agreements, to look at bills. We're looking at things like court cases. And we've been able to generalize away from this specific problem, looking at just industry classification into topic modeling is a big one for us right now, trying to classify different provisions of those trade agreements, see what kind of topics they fall into, because it's a completely different set of concerns. We can answer different questions. And additionally, we've got folks who we've talked to about this system at different economics conferences who are going off and trying to solve their own completely separate sets of problems. And that is kind of the big push here, is that we want this to be something where other researchers can go and either build on using some of the work we've already done, or just start from scratch and do completely different analyses that were otherwise unavailable to them. That's kind of the big picture.
So what's the bottleneck in going from 5 to 50? What's the bottleneck in going from from five states to to a bunch of states?
Obtaining the code.
Oh, really?
Yeah.
That's not machine readable?
Not always, and some states have it locked behind paywalls. Some states have it hosted by somebody like LexisNexis, where you can go and click through it, but the terms and conditions prevent you from spidering it.
But every law firm in one of those states must have full access to it on a comprehensive basis, right?
I have learned to never be surprised at the things that do not exist at the state level for regulatory access. Generally, what happens is we end up writing a web spider to download whatever's on their public website. Some states have very good records going back years. Others have just whatever's up at the time. Some states, one part of the government has to ask us from what we've gotten from another part of the government because they can't get it from the other part of the government. State governments are interesting, complicated beasts. So,
but access to the corpora is the bottleneck. This seems
absolutely,
strange in this.
absolutely. For that particular product, getting the text is the difficulty, and for most projects people want to do, that is the difficulty. Is thinking hard about what classification problem they want to solve is obviously difficult, but just obtaining the text and then knowing how to get the text into the algorithm is something that a lot of people just struggle with. They know that they've got, Word documents in a file or in a folder. Like, how do I make the magic happen? Our hope is that this makes it a little bit easier to make the magic happen, and in a way that is responsible, where at least they're cross-validating well, and at least they're trying out a couple different models. And are guided towards the best practices. Not forced to it, but guided towards it.
So I'm curious, in all the work that Google did to digitize all Western text, I mean, they have not done the law books. Is that curiosity?
I think they stopped doing text a while ago.
But what they did include any?
I found more on archive.org than I have on Google Books. I haven't found anything that is comprehensively indexed so that you could clearly identify. Often what you'll find is one volume, and in a selection where it's treated as a book that would be produced.
That's actually an interesting observation, because a couple of years ago, I thought there had to be a service online for just being able to look through actual federal or state codes.
Yeah.
And it would have been an easy thing just to do OCR on some law books and put them up, but no one has done that, including Google also.
It's amazing.
Mhm.
I always wondered why. I just
Oh, they look too good in the library.
Right.
You know, get
Right.
your picture taken with the books behind, they don't wanna do away with
well,
those.
I'm wondering if it has something to do with whether more people would be convinced that they could argue their own cases in court if they can read it online or something. Maybe there's like a responsibility thing that these companies are.
But some
Yeah.
of these commercial services like Westlaw or whatever it is, I'm just very surprised to me they haven't completely digitized all the state.
Westlaw has. The trick is
Okay.
getting it from Westlaw. Westlaw doesn't want to give it to you.
Oh, no kidding.
Um,
But you guys are an academic operation, right?
Yep.
For example, so we've always been able to get academic licenses for those kinds of deep data dives.
We can get academic license, and this is something where I don't want to talk past the things that I have experienced directly. I don't know how many conversations have gone on. We certainly have access to Westlaw. I can go and read it, but the terms of service for most of these services prohibit you from downloading an entire work. And if we want to create a comprehensive record for time series, which is what you need for text analysis, that's difficult. A couple places, it really does depend on the state as well, and on the deals that the states have with those services. But they are certainly not excited to give away copies. And especially not in the way that, because we are focused so heavily on academic research, even if I got it from Westlaw, I couldn't then give it to you. So
Right,
that
no.
you could replicate my work and know whether or not I'm
But
lying.
I would have guessed, before we had this conversation, I would have guessed that, and I'm happy to be told I'm wrong, I would have guessed that Westlaw charges a lot of money to big law firms to use that stuff. But I would have thought they would basically be giving it away to law students, so they would get hooked on it.
They give away access to the online scans.
Portal.
And you can find those online scans and download up to 200 pages of it.
And
no more.
enterprising law student has ever figured out a way to kind of like download all of JSTOR or something, right? No one's ever done it.
Well, we certainly at the Mercatus Center do not encourage anyone to do anything illegal. We get in enough trouble as it is.
Okay.
So we encourage everyone to follow the law and not.
So this is a classifier, but you just mentioned that you work with time series. What do you do with time series?
So RegData is a time series, in the sense that our data is, our corpus that we're
Time
classifying covers the CFR from 1970 to 2016.
Right. Oh, okay.
So,
And the Federal Register is transactions on that corpus.
right.
And those transactions form it, well.
A time series.
Yeah, yeah,
what-
both of them
we're
form
counting them. Yeah.
time series, yeah.
And is it annual snapshots or
The
is it
daily.
CFR is annual, but published 4 times across the year. If it's very, very important when in the year things happen, then you want to pay attention to that. It depends on which title. But for most analyses, we focus on, like, annual is enough. What's the word? Resolution.
All right. This is, yeah, we're using the word differently. I mean, a stock
Okay.
price time series is something completely different. You'd be doing long-term correlations, a wide range of other tools that we teach you.
Okay, sure.
Yeah,
Yeah,
that-
we're not
that-
doing time series analysis.
Yeah, that's what I meant.
In creating RegData, but we use RegData to do
It's-
time
it's
series
state stamped.
analysis.
I
Yes.
understand.
Okay. Yeah.
Still, there's other interesting tools that we teach here in theory of complex adaptive systems, one of which is for the students to look for Pareto distributions.
Mhm.
And it would be interesting to use some of this output, even your metadata, to see is the number of words in a regulation power law distributed?
Sure.
Or where is it power law, where is it not power law?
Mhm.
I think there would be some interesting investigations that would tell you what has limits and what doesn't have limits.
Yeah.
Where are the natural limits in this system?
Yes.
And where don't they exist?
Certainly for the core RegData data set, I think there are probably $20 bills all over the sidewalk that either we haven't thought of or haven't had time to get to. And so I would encourage everyone, QuantGov.org or RegData.org, either one, you can download our data for the 2.2 version as it's up now. You can actually download that metadata for the CFR 1970 to 2016. That's available now on QuantGov.org. So we'd love to hear about any work that was done on top of that.
Ken, I can tell you right now, the most used word will be shall.
I think you told us that,
Actually,
right? You already did that analysis.
fun fact: shall was outlawed. I forget what year. There's a plain language act. Everyone's supposed to use must now.
Must.
So there's a very clear point. I didn't include that chart here where the shalls keep going a little bit, but then from that point on, the musts take over. Everything else is about the same. We've talked about make, and again, just kind of in conclusion, the point is to be replicable. Anyone can take it and run it. Modular. Each part doesn't have to know about the others. Extensible. If somebody wants to build off of what we've done with the NAICS classifier or off of the CFR and do something completely different, that's hopefully going to be available to people. Many applications can be run on a reasonably powerful laptop. So if you're a researcher working at a small university with no budget, this is something that hopefully can be available to you. It's easy to add and share new features. I just asked two guys who work with me to create an n-gram generator that understands the Corpus driver, so now that can go into all of our projects for no additional cost. It's especially true if everyone shares their code, which is why we're open source, and you can easily integrate other languages and other frameworks. We've done that a couple times. We encourage other people to do that as well. And then, no,
Not too far.
too far. They always said I would.
So my initial reaction when hearing about this was, if we were, a lot of what we do is build agent-based models. So if we were building an agent-based model of some particular type of organization, let's say a nuclear power plant, to take the as an example, could we extract all of the regulations associated with a nuclear power plant and use that to inform kind of the model and as a parameters to drive and constrain the behavior of the model. I mean, I don't. It wouldn't be a trivial thing. A nuclear power plant is not a lightly regulated organization.
No, absolutely.
Or lightly process driven.
I don't know off the top of my head what NAICS code nuclear energy is, but I'm sure that it is one. And nuclear power plants might actually be their own NAICS code. And if it's in NAICS, then you don't even have to do it. We'll do it for you. That'll be in the RegData 3.0 release.
221113.
There you go.
That's a commercial nuclear power plant?
Nuclear electric power generation.
Okay.
It's the
Sure sounds like
It takes 6 digits to get to that?
It does.
Sometimes it's the
Scroll
same
up
between
to
different levels.
Electric power generation.
Yeah.
It's a 5-digit level. Electric power
But
generation.
isn't the case
transmission,
though
and
that
distribution.
you would know? But what's the case though that all NRC regulations are part of the Federal Register? Is that what?
Yes.
That- I would
CFR
think
50.
What about things like I'm just thinking of things like pump specifications and pressure load, all that kind of detail stuff.
That's gonna be ANSI standards or somebody else's standards.
Yeah, that's what I was
So,
asking.
And I presume
so
there's some
that's
state
outside.
Yeah, it's
Yeah.
outside the regulations.
Right.
They're incorporated by reference.
Right. And that is a problem that we've been looking into,
Right.
trying to get solved. We've had some folks look at it on a smaller scale, especially at some of the state levels, where they've seen incorporation by reference. Because it raises all sorts of policy problems, not just in terms of measurement, but also in terms of when you do that and when it's a good idea and when it's a bad idea.
Updates and
Right.
changes.
We have an online
Yeah.
question.
Oh, great.
Just to clarify, if you could go back to the graph of the, I think it was the cumulative GDP, not GDP.
Yes.
You know
Cumulative cost.
which it is.
Their welfare.
Nope, one before that.
Uh-huh.
It was about halfway through your section.
This guy?
Yes.
Okay.
So, nope, not
Nope.
that one either.
All right, I only brought 4 charts. So there's total restrictions,
Sorry about that.
Dodd-Frank.
It's the one with that we had a discussion about when it.
I think that's this
Oh,
guy.
that one, yes.
Okay, yeah.
Yes, I'm sorry. So the question is, it's just about reading the graph. Question is, am I reading that graph right? The shaded area is the range of where the economy would be without regulations since 1980?
Yes, that is the
Or the amount of
confidence
value
bands.
that would be added to the.
Added
economy,
to, right.
Not
Okay.
the,
Because you can always add $1 billion, but it could be, it's gonna grow over time,
Right,
or
so,
$1 trillion.
so now, okay, I'm getting another message.
Okay.
It says it was the one, yes, that's one, so
Okay,
that's the
good.
correct one. It's a time lag.
Yeah.
Yeah, those are the confidence bounds to the counterfactual that they calculated.
Okay.
Which is the slightly, and I guess this might be difficult to see looking over at your screen on the web version. There is a actual estimate and then the confidence bounds.
It's a point estimate.
Yeah.
Yeah.
There's probably, the dots are probably median estimates, the blue is probably the average.
I think the dots are actual.
Oh.
Yeah.
That's why they
That's
extend
what's
before
labeled.
1980.
It says in the
Okay.
header, thus are factual.
You got it, thank you.
All right, great. Were there any
Can't
other
be actual.
online questions or?
Nothing
It's
yet.
not actual,
Alright.
it's factual.
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 As opposed
Sure.
to counterfactual,
There you go.
or alternate factual.
So, any other questions about the framework or about RegData that I can answer for this group?
you do workshops, is that right?
We do, yeah.
And is there a website where somebody could find out where the workshops are done, or?
There's certainly an email and an email distribution list that we can put you on. I don't know. We are redoing our website right now, so I don't want to tell you that content's going to be there if I don't know for a positive fact that it will. But
Everybody's redoing their websites.
right.
Continuous process.
Yeah, no kidding.
Right.
Okay, I'll email you.
Great.
Are you familiar with any data sources for like exotic texts that you could do analysis on? Like maybe religious texts or like really historical texts, like I don't, hieroglyphics maybe, I don't know. Things like would be interesting to look at NLP.
Religious texts are fairly available, I believe.
And this would there's no reason, because it's Python, there should be no reason that it can't handle other languages, right?
Oh yeah, absolutely.
Just-
Nothing
just
about
simple.
this is tied to English. Our work is in English, but that's only because I only speak English.
Yeah.
And we have talked to folks about doing work in other language. Nothing has been finished yet, but there's nothing that locks you into the English language.
Good sources for that are going to be Canada, especially Quebec, and,
Right.
and the UN, because you get multilingual versions of the same documents that you can compare if you need to.
Or,
Right.
or NATO in 4 languages.
No, and in Canada, there's an interesting example related to RegData because British Columbia developed independently a very similar regulatory count, and then used that as a policy target, because, and this is all documented in a paper by Laura Stanley of the Canadian Federation of Independent Businesses, but through Mercatus, where they thought that their economy was too stagnated and that the reason was red tape. They did count through guidance documents, so it's not exactly equivalent,
Yeah.
but they also had interns do it, so it was also more difficult than RegData. And they set a target of decreasing by a third.
Third.
A third. So you can read all about that in Laura Stanley's paper.
But I think when it comes to general symbol interpretation, maybe that's the question. I know there are some difficulties though, because there was a time when I was in graduate school at CMU, and there was one of the early natural language processing groups there. The question was, would it be easier? When it came, the question was nuclear. Would it be easier to understand the Nuclear Regulatory Commission documents in terms of trying to generate measures of, like, you know, how risky is a reactor or something, versus just eating, you know, consuming, you know, using a machine, one of the PRAs, one of the probabilistic risk assessments,
Yep.
which I have one of those in my office. It's like 1,000 pages long, right?
Yep.
But it's full of, it's in essence giant decision trees, but with other stuff in there too, like, you know, just, you know, like exogenous factors and stuff. And so, and I think that I remember just this is 1990 now. I just date myself and to date the whole thing. I think that going into it, the thought was it'd be easier to parse the PRA than actually to parse the table of regulations.
But the regulations only say what the boundaries are for how you do it. The PRA is customized to an individual power plant.
Exactly right.
And as built as opposed to.
And so the claim afterwards would be that it was very hard to interpret the PRA and very hard to do much with it because it was in some sense a self-contained document,
Yeah.
and so it ended up being that was kind of a dead end. That was kind of a cul-de-sac that was and I think that the corollary was that in general kind of formal mathematical text is actually wickedly hard to properly interpret, just because it has a very socially constructed meaning for all of us who are part of it, but it's hard for the machines to discern that. And this is all tied up at the same time. Herbert Simon was doing this logic of scientific discovery. What he wanted to do is he wanted to eat Tycho Brahe's data on the planets and spit out Kepler.
Yeah.
So that also is a hard problem.
Well, you know,
For
that
raw
there's
data, yeah.
studies to indicate that
Some genius is required, right?
that the data doesn't support Kepler's conclusion.
Oh, I don't know that.
Kepler fudged, yes, there's
Oh, I
an
see.
interesting book on that subject. Kepler.
That's fascinating.
Kepler, basically, the data was not sufficiently precise to show that the orbit of Mars is elliptical.
Oh, okay.
Or to differentiate between a circular and elliptical orbit. When you finally get into it and do the math, and Kepler had a weird way of doing his math and all that stuff, but, that was written up in the Journal of Astronomy or something like in the 1990s.
So it's almost like you need a little bit of religion to do a little bit of science.
That's about the size of it, In other words, he knew the answer he wanted to get, and he wrote something that was so complex that
That nobody else could check
nobody
it.
could check it.
But, I mean, look, if it was precise, it would still not fit because
It'd be off by
all the
something.
planets perturb one another.
Yes, they do.
So,
Yes.
science does require faith, right?
Yeah.
It's just that,
Yes.
forget about anything other than that.
That and the proof of Einstein's general theory being, special theory being true based on the collected data from a 1916 or something,
Oh, the Eddington experiment.
the Eddington experiment, where the noise was equal to what they had for results.
Well, thank you very much for your time, Albert.
Yes.
Thank you so much for that.
I'm not sure we'll have any heavy users of your stuff here, but possibly.
Yeah, plant the seed.
Right.
Too, yes, but feel free to if you I mean we have people here with decent expertise, and we have good connections over to computer science where they do a lot of machine learning stuff, and they have machine learning researchers. So
Great.
we have been involved with various proposals that they worked on about particularly financial data, that kind of stuff.
Great.
Using machine learning techniques. So happy to stay in touch with you guys as you guys build your stuff out, and maybe have you come back next year when you have some new stuff to report.
Yeah,
Version
absolutely.
3
Yeah.
And thank you guys so much for
Yep.
taking the time.
Very good.
I'll make sure
Yeah.
you get my card. and everything.
Great, I've already emailed you.
Oh, fantastic.
The wonders of modern computing.
And thank you especially for letting me use your other laptop.
Yeah.
I'll take your card, because you
Absolutely.
realize when you run out of cards, you have to get promoted.
I do.
Well, the big class is done.
Oh,
So
okay.
I just need